Hello and welcome to another tutorial of the FPS game, and in this tutorial we will actually attempt to make the zombie class, which is, as you can see, the last real bigger class. Later on we obviously can make another classes like item or knife, and we can add better models to the game, but this is actually the last piece for the game engine. Our game is actually quite nice already. Okay, the textures are, and so the models are really crappy, but other than that we have shooting, we can aim, and we can move. So this is already quite good. Okay, so let's start to make the zombie class. So I created the two files, zombie.h and zombie.cpp, as I always do. And first of all, I make the inclusion guard as always all of my classes. So if not defined, zombie underscore age and if, and here the zombie class definition will come, so call it zombie. Alright, let's start to add the properties, and I will care the includes later. So first of all we need a vector which stores the images for the zombie animation, similarly as we did with the weapon. So unsigned int, and I call it frames. Okay, and we need three variables to store the different kind of animation. So how many frame is in one kind of animation. So how many frame is the walk, the attack, and the dive. So that's what I will define now. So walk, attack, and die. Okay, and the current frame, so unsigned integer current frame. So pretty much this is actually pretty similar to the weapon class. We have all of the frames, we have each frame, each of the states, or we can call them states or modes, how many frames there are in walking, attacking, and dying, and the current frame. Okay, by the way, I should mention that because there could be several zombies with the same frames and the same animation, maybe you should make this into a class as a public property, so as a template you could use that. But because now every time we create a new zombie, each zombie will store the exact same things in here. Although because this integer is just 4 bytes, I don't think that it would cause problems just mentioning it. Okay, the next thing to do is quite a few of the properties of the zombie, like the health, so int health, and the strength. So these are pretty self-explanatory. So the health is how many health the zombie has, and the strength, if the zombie attacking the player, how many health should the player lose. Okay, and it has a speed as well, so float speed. The game could be set harder if we set the speed bigger. Okay, next is two vector 3D objects. So vector 3D, you remember the class we defined in the first tutorial, I guess, and this is one of them is the direction, and the other is the rotation. The direction is basically a vector from the zombie to the player, while the rotation similarly a vector, but stores the x, y, and z rotation. We will not really rotate on the x and z axis, only the y axis, so it will rotate toward the players, but if we want, we can rotate on the other axis as well. Okay, we have three flags coming up, so this is the is walk, and the next is attack, and the last is dead. Okay, these are kind of, again, self-explanatory. This is similar than the weapon class current mode. So in the weapon I called cur mode to determine which mode is it. So similarly I could do that here as well. So if the current mode is 1, then we are walking, as zombie is walking, we are not walking. The is attack is, for example, 2, and the is dead is 3. Although I will make it as boolean flags. It doesn't really matter. If you want, you can use an integer variable as well to hold that. Okay, and one more member variable. This is the collision sphere. So collision sphere, which is obviously store the collision sphere of the zombie. So which is the radius and the center point. Okay, and let's make the public function. So first of all, as the constructor, as I usually do, this will weight the frames obviously, so I copy that to save time. So it's a vector of frames called anim, actually just a reference because it's more efficient in this way. It will weight the walk, attack, and die, so how many frames each of these animations are in this array. So unsigned integer and w for walk, unsigned integer a like attack, and unsigned integer d for die. Okay, the current frame we don't need to ask because that will be internally calculated. The health and the strength we have to get as a parameter, so int call it age and int str like strength. Alright, the speed obviously needed to be included in here, so float sp like speed. Next is these are internally calculated, and the collision sphere, so the last parameter is a collision sphere, right, and call it CCS just so we don't have to use this pointer if we not call the same name. Okay, although we don't have anything dynamically allocated here, I place the destructor here, so I actually do the definition right here. So if we have something later on added to this class which is dynamic, then we can easily just pass in here the delete or free or whatever we want to do. Okay, next is the show and the update function. So let's start with the update function. So this is returned with the boolean. If it is true, then the zombie died in this update, else it will return false, so the zombie not died. Okay, so call it update, and actually it weighs two parameters. The first one is a vector of collision plane, so basically the map, as you probably get. So vector and collision plane. Similarly as we did Similarly as we did with the player, it get all of the collision planes, and then we can use a for loop to go through all of the planes and check against this collision sphere we have right here. And if there was a collision, then do some respawn, and yeah, that's basically it. So it will not fall through the ground. Okay, and let's just call it call, and the next parameter is actually the player's position. This is needed because we want to walk toward the player, so we have to know the location of the player. So this is a vector 3D and the player location. Right, now we need the update, show, I mean, so show. The show function is pretty much just show the zombie in the current, in the place where it should be shown. Okay, function is, new function is the set attack, so bool set attack. And this with the collision sphere of the player, so collision sphere and player. Right, so this set attack will return true if the player is close enough to the zombie to attack. So the zombie so if the zombie attack the player, it will return true, as it will return false, and it will set these two facts correctly. So if the player is far away, then we walking and not attacking. If it is close, then we attacking and not walking. That's what this function does, and we need a lot of getter and setter function. Not that lot of, but quite a few. So first of all, we need to get the collision sphere sometimes. So get collision sphere, right? And we have to set the location of the zombie. Maybe later on we have to set the location. I do not remember if we use this actually or not. But anyway, if later on we will add something which will set the position, then we can just call this function. So set location, right? And it will be a vector 3D new location. Okay, then we have a decrease health function. So decrease health. So if the zombie is shot, then we will decrease its health. Right? The next thing is get the health, which is just return with the health. So if we want to add the, I don't know, title about the zombie to write out how many health is left, then we can do that. Okay, the get strength is the next. So get strength. So if this set attack return with the true, so the zombie attack the player, then we need to get the strength of the zombie and decrease the, so we have to subtract this strength from the player strength later on, obviously not now. Okay, and one more is the is dead function, which is obviously just return the is dead variable. Okay, let me just copy this to the other file, and as I usually do, I will format a little bit this code. First of all, I include the zombie.age, and hold on, I will format this code. Alright, here I am back, so I hope the keyframes are okay. And actually I made these really simple setter and getter function, like just returning the corresponding value to the name and do the corresponding simple operation which it says. So these are very simple. I just don't want to take the time of the tutorial for that. Okay, and also I formatted the code, added this zombie colon to everywhere where it is needed and where I didn't forget it. Okay, so the constructor, it's pretty simple. As always, we have to just fill up these values. So the frames equals to the anim. Okay, the walk equals to W, the attack equals to A, not attract. Okay, and the die is equals to D, strength equals to STR, speed equals to SP, collision sphere equals to the collision sphere. Did I forget something? For speed, health, yeah, health equals to H. I think we have set every value. Now just set the rest of the values which are here. So for example, these flags, the walk is true, so when we create the zombie it will be walking, not attacking, and not yet dead. So these are false. Next thing on the list is, I set these, I will set these in the direction, so for now just leave them as 0. The speed, the strength, health. Okay, I think I set everything which was needed. I deleted the destructor here since I have the destructor, actually the implementation right here, which is actually just an empty bracket, empty nothing. Okay, so next thing is the show function. Actually, before I do the next thing is the update function. So in here first I have to check if the zombie is dead or not. So if not is dead, so the zombie is not yet dead, then we can do the following things, like for example get a vector which points from the zombie to the player. So direction, the change, so player location minus the center. So this is a vector which points from the zombie to the player, I believe so. Okay, and now I normalize actually this vector, so direction dot normalize. So basically set the length of this vector to 1. So we can easily calculate with it. Next thing on the list is actually do the collision detection and gravity. So I need to make another vector 3D object, and I call this new position, and this new position will be our current location at the moment. And then I add the gravity right here, so new position.y and minus equal 0.3. That's about the gravity I think I set for the player. Of course make it falling. Next thing to do is to make it moving toward the player. So I can do that by new position and plus equal the direction, which is a vector pointing toward the player, times the speed. So it's basically mean that we get the vector which pointing to the player and we move toward it with the speed. So of course if you know the vector operation, this is pretty straightforward. Whenever we multiply the x, y and the z coordinate of the direction, because the direction is defaultly 1 all cases since we normalize it right here. So the zombie will move with the same direction, not depend how far the player is, and we multiply it by speed. So if the speed is big, then we multiply 5 units per frame. For example, if the speed is 5. If the speed is 1, then we working with 1 unit per update. And if it is 0.2, then we go 0.2 units. So it's kind of simple. Alright, and now I will do the checking, so collision checking. I go through all of these collision planes. So int I equals 0, I less than call dot size, so all of the planes, I++, and I simple call the collision colon. I just realized that we haven't included anything. I will do that in a moment. So I will call the sphere plane function, which is do the response for the sphere and the plane collision. First of all, the parameter is the new position, so new position, which is actually currently the current position, but it will be a new position after this we run this program, because the response, so the new position will be in this. Okay, and we need a normal vector of the plane, so this is the call I dot normal, and similarly I need the 4 point of the plane, so call I is dot p0, which is the first point. So If you don't remember, go back to the collision plane definition, there where I set this normal and p array for the points 1, 2, 3. That's right. So this is the third, second, and first. Okay. So the last parameter of this function is actually the radius of the sphere, which is in the collision sphere structure, which is right here, filled up with the radius, and we call it r. Okay, so the new position will now contain the new position where we should place the player, so we call the setLocation function, setLocation, and the new position. Right, so this setLocation is down here, so just basically set the center point to the new location. I could have write that in here, but maybe later on we have to do other things whenever we set the location. Okay, and one more thing is remaining to do, is to rotate the zombie toward the player. So this is done with a little trigonometric function. So get the rotation.y and make it equal to std cos, which is the arcus cosinus, which is actually the opposite of the cosinus. So cosinus 90 is equal to 0, if I remember correctly. Then a cosinus 0 is equal to 90. So just the opposite, basically. Okay, by the way, these are angles, degrees, not so these are degrees, not radians, as the C++ cosinus and A cosinus weight. Right, so here we go, and actually I get the direction .z from this. I will show an image in a moment. So one more thing to do is actually this rotation is work correctly toward the player sometimes if the direction.x is greater than 0. So if direction.x is greater than 0, then we actually negate this. So rotation.y equal to minus rotation.y. Right, so yeah, it's a bit complicated. Basically all we did here is whenever we normalized this direction, it basically created a unit circle. And then with a little drawing I should show you, maybe, I don't know, later on, we can get the cosinus. So we can get, yeah, the cosinus. Similar to that, I don't really understand either. I understand this part, but I don't understand why we have to negate it. Anyway, I just figured it out, write out the values, and I see that whenever it's not working correctly, the x is greater than 0. Right. Okay, so this part is not really that important. Okay, now we go outside of this if-is-that function and actually check if the zombie is just now died. So if health is less or equal than 0 and the zombie is not yet dead, so is that equal to false, then the zombie just now died. So we have to set the is dead equal to true, since the zombie died. The is walk and is attack equal to false, since the dead zombie not walk or attack. And we have to set the current frame equal to the walk plus attack. This line is similar to the previous tutorial weapon class, because in the zombie file, in the frames, so right here in these frames, the animations are first a walk animation, then an attack animation, and then the die animation. Right, so again, if you don't understand, you might want to go back to the previous tutorial. There I made a simple example. Okay, and I just returned with true, so indicating that this zombie is just died because it's a boolean. Okay, and outside of this, I just increase the current frame, so current frame plus plus. Of course, because one update is path, so we have to increase the frame in order to have an animation. Now we have to set back the animation to the correct frame. So if the zombie is walking and the current frame is greater or equal than walk, then we just set it back to 0. So curve frame equals to 0. Right. The next thing, so else if it is attacking, so is attack, and the current frame, so curve frame is greater or equal than the walk plus attack, then we set it back, so curve frame equal to walk. Okay, so again, if you don't understand this part, you should go back to the previous tutorial. I added an example here. but I think it's very logical. Else, so the player is dead. I should add an if here. Else if, so if the player is dead, so is dead, and the current frame is greater or equal than walk plus attack plus whatever die, yeah, then we set back the current frame to the last frame in the animation, so walk plus attack plus die, because we don't want to play repeatedly the dying animation. Of course we want to play repeatedly the walking animation, the attacking animation, but once the zombie is died, we should not play the dying animation again, so it just set it back to the last frame, which is, I don't know, the zombie is just lying on the ground or something. Right, now we just return with 0, indicating that the zombie is not died in this update. Okay, next is the show function, which is a bit simpler. First of all, we have to push it back to the matrix, so GL push matrix and GL pop matrix. So again, we will not screw up our transformation matrix outside. Okay, and first of all, I translate to the correct location, so GL translate F to the current location, which is the CS, the center, which is our collision sphere center, which is the position, and the X coordinate. Similarly, I do that with the Y and the Z. So Y, Z. Okay, next I rotate the zombie, so GL rotate F. GL, I said GL, okay, I get it. GL rotate F, and this is the rotation dot Y times 180 divided by m underscore pi. This is how you calculate the radians from degrees. Okay, and we rotate it in the y-axis, although this will be 0 because I don't think that oh, this is x I wanted to write, not c, not y, x, that's right. It's a little dark in this room, I can see the keyboard, although I used to my old keyboard. This is another keyboard I used to type. Okay, then the y and the z coordinates, and the y should be in the y and the z should be in the z. Okay, so this is pretty simple OpenGL stuff. This is just converting the radians to degrees, because GL rotate F weights degrees. Okay, and one more thing, actually I want to scale this zombie because I never succeed to get the correct size of zombie. So it's either too small or too big, so I can just use a scale for that, GL scale F, which is just basically resize the zombie. And for the moment, since we don't have any zombie model, I just pass 1, which is basically have no effect. Okay, and just display the list. So GL call list displaying the current model, which is the frames and the current frame. Okay, so we did this earlier, nothing new in here. Okay, next the set attack function, which will return with true if we can attack or false if we cannot. Okay, so I have to use the collision sphere collision detection, which is return true if the two spheres is touching each other in any way, return false if they are not. The first sphere is the player and the second sphere is the zombie. So if the two is touching each other, then the zombie can attack the player, else it cannot. Okay, and in here set the is attack equals to true, so the zombie is attacking. The is walk and the is dead. The is walk is false. We don't have to care about the is dead here. I will set the is dead in the update function if you remember. Okay, and just return bit true, so the zombie attack the player, else do the opposite thing. So I just copy this, paste this, and false, and this one is true, so is walk is true, and we return with false. Alright, I think we are pretty much finished with this zombie class. I said it will be a little bit simpler, so let me open up the game .cpp and h file, and we make the zombies right there. Alright, here I am. I opened up Blender. This is the newest version 2.63, and here is the default screen. So one cube, one camera, which we doesn't need. And actually I said that I will open up game.cpp, but we cannot do much without the animation. So first of all, let me create the animation, and then we go back to the game.cpp and create a whole bunch of zombies. Okay, so the zombie model will be very simple. The same rule applies like in the weapon class. Make it as simple as possible to be quickly able to load it. So first of all, this will be the chest of our zombie, this cube. So press S and Y to scale it on the y-axis, so SY. Okay, and here is the chest of the zombie. Now I add another cube, so space and just type add cube and choose it from the list. Okay, scale it down a little bit. This will be the head of the zombie right there. Okay, and then make the arm. So again, add cube and scale it up quite a bit, even more. Move it up and scale it on the z-axis, so S and Z, and just about that. Right, and I will copy that to the other side, so I will use Shift D and X to move it on the x-axis. So first press Shift D to duplicate, and then the X to able to move on the x-axis. By the way, I use these arrows often. Right, here we have our upper body of the zombie. Now I just add a leg, which will be the same at the moment as the arm. So I will just move it right here. Again, I use Shift D to duplicate, and then a letter to which axis do you want to move it. Perfect. Here is our simple zombie, and we have to animate this. So in order to do that, one frame will be our normal animation. So again, I will just open up a file and just write 1, because one frame will be the normal animation, and select actually everything. So I just pressed B and just selected everything. So use a little, how does it called, a cube, or no, it's not cube, it's square around all of the objects. As you can see, everything is selected because it's reddish orangish. Okay, and press I add keyframe for add keyframe, and location, rotation, scale. Perfect. Now the first thing is the walking animation. So I go up to frame 10 and move and rotate one of the legs. So rotate the leg on the x-axis. Move it forward. Okay, here is one leg, and the other leg rotate on the x-axis will go backward, right? And with similarly with the hand, so RX, rotate it, move it back, and the other rotate it, move it this way. About right. Never mind if there is a problem. So we don't have to make perfect animation at the moment. So again, press I and location, rotation, scale. So you can go back and see how does it look at the moment. As you can see, it is putting one leg after the other. So I go back to about frame 80 and move a little bit more, 25, and move everything to the opposite direction. So set this and rotate it on the x-axis, and what should I do? Maybe not. Okay, so rotate it on the x-axis, move back, and the other leg rotated on the x-axis, so RX, if I didn't mention that, and move it forward. Similarly with the hand, rotate X, and just move it, and here rotate X, and move it backward. By the way, there is a way to set the center point of this cube to be here instead of in the center, so it will be easier. Okay, again, before I forget, I select everything, I location, rotation, scale. Okay, here is our simple animation so far. Simple animation starts from here. Not that bad. Okay, and I go back to 30 about and set back everything to the initialized position. So rotate it on the x-axis and move it forward, and rotate it on the x-axis, move it backward, rotate it on the x-axis, move it back, and rotate it on the x-axis, move it forward. Okay, so as I said, it doesn't have to be perfect, just so we can see and do something with it. Okay, and select everything, because sometimes I forget this step and I have to do it again. So here is our simple animation, moving. Now the next thing is attacking, so go back to, I don't know, frame 40, and just do something with the hands. So x-axis, and rotate it on the x-axis and move it right here, and this hand should rotate it on the x-axis and move it right there. Okay, and again I select everything, I location, rotation, scale, I move it forward 5 frames and rotate it a bit, so X, now it is like that, and X, and I should move a little bit up. So again, I location, rotation, scale. So the simple attack animation is just this hand wave right here, and 10 frame forward I just lower back the hand, so rotate it on the x-axis, and again it don't have to be perfect, a little bit lower. Okay, now the other hand, so rotate X, little bit backward and down. select everything, I location rotation scale. Okay, so probably I should have wrote down how many frame was it. So the walking is, actually we don't have normal animation anymore. What did I do here? Never mind. So there's 30. Perfect. So I write down that 30 frames is the walking, and then 20 frames is the attack, and now the dying, which is okay. So in 60, for example, I don't want to make too many frames. Just make this zombie dead. So rotate it on the, what should I do? Just select everything, rotate it on the x-axis, and here is a dead zombie. Okay, so just location rotation scale. So the dying animation will be like this. So the zombie will completely unnaturally fall down to the ground. And actually I should move it down a bit. Right, our location rotation scale. That is our dying animation. So the zombie will just fall down. Okay, and actually this is, how many frames was it? From 50 to 60, 10 frames. Okay, so all have 60 frames, which is about 2 seconds, little more. Okay, and now I have to just render out this simple animation, so we can test this out. And I set here in the render tab the end frame to 60. We don't want to render a lot of other frames which there are no moving in. So if I run the animation now, walking and attacking and the dying, walking, attacking, dying. Right, so I will save that as object file to my home, to the FPS game data, and I created a folder called zombie1 for this, and I call it zombie zombie.obj. Oh, so dark in here. Okay, and include the normals, and it make it an animation, and we are ready. So export out the object, and it is exported out. Fantabulous zombie, and here are our 60 frames. With the size of this is 200 kilobytes, which is not that much. Okay, so now I can go back to programming. Stay tuned, I will be back. Alright, here we go. I just open up game.h and game.cpp file and the player.h file as well, so we can see the function names if we need to. Right, so I should create a vector containing all of the zombies, so std vector, and these are zombie, which I should include zombie zombies, and call it zombies. Okay, and let's include the zombie header file, so include zombie.h. Okay, so let's add the zombie to the screen so we can see if it is working or not. So in the constructor, under these weapons, I add a new zombie. So zombies.push back and a new zombie. Okay, and let me see the what value that it's waiting for. First of all, the animation. So let's load that. Actually, we can use this animation vector which we created right here, anim. I just have to first clear it. So clear. Now the vector is empty, and then I can call the load animation function again. So load animation, and this load animation first parameter is this animation, the second is where the zombie animation is, so data slash zombie1 slash zombie. Okay, and the number of frames is 60. Right, now this is the first parameter for this zombie constructor. Next, the walking, the attacking and dying animation, so 30, what the whole numbers. Okay, so these 30 and then 20 and then 10. Next thing is I go back, so walking and dying. Okay, the health and the strength. Okay, I don't know, 100 and I don't know 5 or something. Next is the speed of the zombie. That's a good question. What should be a good speed? I don't want it to be too quick. Make it 0.2 at the moment. Later on we will modify it if it is not good. And then a collision sphere. So collision sphere, and first of all the vector 3D for the collision sphere constructor, and the position, make it above the level as well, similarly as we did with the player. So make the x coordinate to 5, the y is 10, and the z to 0. Just a random number came to my mind, and make it how size did we make the yeah, free? We make the weapon. What? I don't know. I don't already know what I'm talking about. So the player. What the player? Yeah, the player. The collision sphere size is 3. So let's make the zombies as well. So 3.0. But although I think it will be a little big. No, I don't know. Maybe we will see. Right. Okay. One more. Now. Here we go, we have a zombie, so let's call the necessary functions for that. Oh, of course delete it after we finished. So for int I equals 0, I less than zombies dot size, which is currently just 1, I plus plus, and just what am I typing? Delete the zombies I. Right, next in the start, just let's go, and actually in the update, let's call the update function for every zombie. So I will do it right here. So again, a simple for loop, zombies size I plus plus, and just call the zombies I and an arrow because it's a pointer update. And actually we should check later on if the zombie is dead. So if this update function return with true, that means the zombie died. Okay, we do something here. Zombie died, like increase the point, drop a weapon if we want to. Okay, and in the show function, let's just call the show function of the zombie after the update camera, so it will seem to be static on the level. So again, a simple for loop, I less than zombies size I plus plus, and just simple zombies I arrow show. Okay, and one function is this set attack function, which we should call. Similarly, I go through all of the zombies with a for loop, and if zombies I dash set attack, so if it is returned with false, yeah, it will return with true, then the zombie is attacking the player. Oh, and we should pass a few parameters to both the update and the zombie, I believe so. So the update is waiting for the collision planes, which we have level 0 arrow get collision planes, if I remember correctly. Let me open it. So level.h, here it is, and get collision planes. This is written with the collision planes, obviously. So get collision planes right here. Okay, and the second parameter of this is the player position. So player 1, and let me open that one as well. Get position. Oh no, where is the get position? Get collision sphere. Okay, I get the collision sphere, and from that the position. So get collision sphere dot center, which is the position. Right, and this is the 2 parameter for the update, and for the set attack, the player 1 arrow get so this one which I used here, get collision sphere, is needed. Okay, and here is the 2 important functions which we should call, and now we should debug the program, because I think we are pretty much finished. We have to add some things like here and here, but that's after the testing. So again, I am in the correct folder, and I try to compile it. It should be here. Okay, not that much of an error. Okay, that's a lot of error. Collision planes was not declared in zombie.h. Nothing, because there is no collision planes, but collision plane there is. And I forget to include, of course, although I mentioned it, and I still forget it. Incredible. So I need the vector, I need the CMath for the Arcus cosinus CMath, I need IOStream just in case, IOStream, I need the collision vector, so collision, not vector, collision header file, and similarly I need the collision plane and collision sphere header file, collision sphere.h and collision plane.h. What else do we need here? The vector 3D, so include vector 3d.h. Okay, I run out of idea. What else should we include here? I think nothing. Okay, let's try to compile it again. Maybe this should fix some of the errors. Okay, that's handleable. Template collision planes, still I write collision planes in the CPP file, I forget to change there. So collision plane instead of planes, because that's how our type is called. Okay, let me put it back. 1725, the update. Okay, you're right. Okay, 66. No matching function to sphere. Sphere. I'm pretty sure it's called that. So 66 sphere. I can't see now the problem. Let me open the collision header file. So collision.h, and here we should have a sphere. Did I mistype that? I will copy it so there will be no mistype in that. Sphere. No, I didn't mistype that. Oh, sphere. Not sure then. Let me try to compile it again to see if this error is still there. Oh yeah, I see, we passed wrong parameters. Sphere, which is, wait for the radius, obviously it cannot know the radius, so player dot center and player dot radius. Similarly here the center and the cs dot radius. Now it should be okay. Let me try again. Alright, seems that it compiled, so let me try to run it. And here it is. And as you can see, I'm never able to actually get the right size for the zombie. Okay, the zombie is definitely following, and it's definitely not turning in the right direction. Okay, so the following is working fine, it's following. Okay, so I should scale the zombie a little smaller. That's why the scale is here, so use 0.6 apparently. So 0.6, 0.6 and 0.6. Right, okay, so now we have the zombie scaled a little bit down, and the next thing to do is actually, what is the next thing to do? Find out why the zombie is not turning the direction as it should turn. So get the rotation equals to arcus cosinus direction z, and this code is the same as I did in the original project, and in the original project it turned rotation x, y, z multiply 1. It should have worked. I'm not sure about that. Let me compile and run it again. Okay, here we go. Still we could rescale it a little bit, it's a bit too big. Apparently the zombie is a bit too quick. We should slow down the zombie a little bit, so go to the game.cpp and set the speed a little bit smaller, so 0.2 instead set it to 0.1, and again just try, and if not working then set it, compile, try. That's our tactics for now. Okay, a little bit better. So this zombie doesn't turn anywhere, I see. Or does it turn? I can't see. I think it's not turning. Or is it turning in the opposite direction? It should, maybe. So I go here. I'm not sure. Let me just comment out the part where it's translating, so we can see if it is actually rotating or not. So the zombie now should be in the same place. It will be easier to see if it is rotating or not. Oh. Okay, so if I am going this way, yeah, the zombie is rotating, but in the wrong direction, I think. Isn't it? Still, it's hard to tell. But if it is just rotating in the wrong direction, let's just put a minus sign right here and see if it is work. Again, just try, and if it's not working, then try something else. This is the tactic for today. Okay, so I mean, it's turning, but it's turning a bit quicker, isn't it? No, I think it's kinda okay. Yeah, it's kinda okay. Not perfect, but we will work on that later. So I had to put a minus sign right there. Okay, the next thing to do is what is the next thing to do? Oh, right, we have to add something to these sections. When the zombie died, we don't add nothing there. We will add later on the item, so it will drop an AK or something. But when the zombie is attacking the player, we should decrease the health of the player. So player one, and use the decrease health, if I remember correctly. So player.age, and we have add health. No, where is it? We didn't make such function. We just have this set health and get health. So we have to use these two functions. So set health, and I get the player one get health function, and I subtract the strength of the zombie. So apparently this is the zombie's eye get strength, obviously. Right, so now the player's health is increasing. Actually, let's just write it out so we can see if it is working or not. So stdc out and player 1 get health, and make a new line here, and we can see if it is working or not. Okay, wait a bit while it's compiling and we can test this out. I believe it will be a long tutorial as well. So here we are, and yeah, it's definitely working. So it's decreasing the health, although you can't see it because the terminal is in the wrong place, but it's definitely working. Little problem here, the zombie get inside me, although it shouldn't get inside me. That's because one of the or both of the collision spheres are small. So let's go to the game.cpp and increase the size of the collision spheres to 4 or 5, whatever. Now we should try out again. This is kind of like this from this moment, so just trying out new stuff, and luckily we made a oh, sorry about that. Now just I can grab this. Okay, still it got inside me. Why it got inside me? It should stop there. When it is attacking, it shouldn't follow, right? So let's get back to the zombie class. And if it is attacking, then it shouldn't follow me. So set if not is attack. So if it is not attacking, actually this is not capital, then moving. As if it is attacking, then the zombie not moving toward me. So let me try that again, and we can see if it is worked or not. All right, here we go. And as you can see, attacking and stopping, and now the collision sphere are definitely definitely big. Now we can see it. So set it back to 2. Right. Okay, compile and run. Okay, here we go, and see. Okay, that's I think correct. So this is the distance when attacking. Now the next thing to do is actually implementing the firing. So if we fire to the zombie, then it should of course decreasing health. We can do that wherever we did the fire handling. So we call the if mouse button down, then fire with the current weapon in the direction. So we can use the collision ray tracing. So collision : ray sphere, I believe. So ray sphere, and whatever parameters it has, I'm not sure about that right now. Probably, as you can see now, I'm not working from cheat sheet. I find out this stuff now myself. So that's it. Okay, so I just copy this here so we can see as we type. Control V. Okay, and for I have to run a for loop. So for int I equals 0, I less than zombies.size I plus plus, zombies.size I plus plus, and for every single zombie I do a ray tracing. So if this return true, ray no, this is the sphere. I copied the wrong thing. Okay, that was a fail. Let me go back, and where is our ray sphere or something like that? It should be ray sphere, the first one. Oh no, we still hasn't updated. I still hasn't updated it to get vector, so now I have to pass all parameters manually. I should have done that. Anyway, I will not do that right now, so I pass all of the parameters. So just pass it right here. So the center position of the sphere, XC, which is the zombies I get collision sphere dot actually arrow, because it's written a pointer if I remember correctly, center dot x, and I do that with the y and the z as well. So yeah, here it's one line. Okay, y z z, I said z y. The next thing is the direction of the ray. Yeah, the direction of the ray, which is the direction.x, y and z. Direction.x, y, z, z, y. That's right, the direction of the ray. The next thing is the starting point of the ray. So float x, yeah, the starting point of the ray, which should be the player's location actually. So player 1 get location dot x, and similarly I do with the y and the z as well. So y and z. Okay, and what else do we have here? The distance and yeah, the point, which we don't really need that. These are default parameters right now. So yeah, so if this long if happened, then we hit the player. So let me write out something here for the moment. So stdcout hit the zombie and make a new line. And actually I will find that place where I did the other writing out, since we will not see anything from that write out, if it makes any sense. Although I have no idea where I did that other writing out. Oh, there we go. Here it is. So I just comment it out. Right. So actually I will call the right functions right here. So what is it? Zombies I arrow decrease health, and we decrease the health with the strength of the weapon. So player 1 get current weapon, and I get the strength of this weapon, if I would know what the function name is for that. Strength. Okay, I just search. Yeah, get strength. It's a pretty simple name, actually quite logical name. Okay, and another. Okay, this should work or not, and then we are screwed and we can find the error. Let me delete this and try to compile this whole thing. So again, compile and check to see if we have any error. No get location. Then was it get position? Okay, this lot of function name player.h. Here we go. So get collision sphere, of course. Get collision sphere and the center of the get collision sphere. So get collision sphere dot center dot x. Okay. Similarly, I do in here and here. So copy and paste, and again paste. Okay, and change this to y and change this to z. There we go. So we fixed this for error. We have no decreased health in the zombie file. What does that be called? Get health, decrease health. This is it. Decrease health. Did I mistype that? Seems like decrease. Yeah, I mistyped. Decrease. I mistyped that in the zombie file actually. There should be an A there. Decrease. Never mind. Just leave it right there. Okay, and we are not close one of the something we didn't close. We did. Okay, I closed that. And if mouse, of course I don't close that if mouse button down thing. Now it should ray sphere is not member of the collision. Of course that's a ray sphere with not capitalized S. Ray sphere. Whew, that will be a long tutorial again. Oh, I fixed 5 error and I get 10 back. Okay, I should close some parentheses apparently. Of course I haven't put a point right there. Okay, what else? Let me try it again. I get more and more errors. 117. Yeah. Okay, we are in the right line. Oh, one more. Now, this was a ray sphere was only one that was closed. The other one is not. 170 again. No matching. Oh, some parameters are wrong. So we have 3 floating point values, another 3 floating point values, and 3 more. So we have 9 floating point values. Isn't that correct? 3, 6, 9. Oh, a radius. We missed a radius. Okay, the radius is the zombies eye get collision sphere center dot or not center, but get the R from the collision sphere. Okay, try it again. Oh, what? Okay, something is definitely wrong. The default parameters are not working, or what? Collision. I set the default parameters to null, so let me check. Okay, so again, the parenthesis was in the not the correct place. So now I can compile it if everything goes well. If not, then we are going to debug in the entire night. But it does work. So now if I am shooting, hit the zombie. If I am shooting in the different direction, then the hit the zombie will not come up. But why does the hit the zombie come up 4 times every time I hit the zombie? And why does the zombie not following me right now? Probably it's because it's dead. Okay, so hit the zombie is not. So why does it come up so much times? Oh, we should check if the weapon actually fired. So if the weapon is actually fired, because if you remember, this is returned with true or false depending on whether the weapon actually fired or not. So we should put everything in an if. So we only want to check if the bullet hit if the weapon actually shoot. If we're just holding down the mouse button but the weapon is actually not shooting, then obviously we don't want to check. The other problem we have seen is that the zombie haven't died. Why not it died? So the dying animation not working correctly. Okay, now if I hit the zombie, okay, if I hit something else, it's not right out hit the zombie. Okay, I hit the zombie a few times, probably it should be dead by now. Yeah, it's dead right now, but the walking animation is playing. So why is the walking animation playing when the zombie should be dead? That's a good question. So let's go back to the zombie CPP file and we will debug in the entire night. So if the health is less than equal 0, not dead yet. So let's write out if it's actually working. So it's write out that the zombie is dead. So in here the zombie is dead. Let's just write out that the zombie is dead. So std cout, the zombie is dead. Std end line. Alright, and try it again. Before I actually do that, I go back to the wherever we created the zombie and I decrease the health so it doesn't take that much of bullets. So decrease the health to 20. So it should be pretty much 1 or 2 kill, whatever the strength of the weapon. Right, okay, it's running. So here we go. The zombie is dead. Okay, so it's correctly getting back the value that the zombie is dead, but still the animation is not playing. So is dead should be true. Okay, so current frame of is the walk plus attack, and I'm not sure why. Okay, I have the problem. I think I have spotted. The problem is that I've set the isWalk back to true whenever the player is close enough. So first of all, I should check if the zombie is actually alive. So is alive? No, is dead. So not is dead. So if the zombie is alive and then the player is close enough, only we do that check there, or else. Is there wait a bit, doesn't set the isWalk to, so only set the isWalk to true if it's alive. So if not is dead, then set the isWalk to true. Now it should play the animation, that animation when the zombie is dead. By the way, now it's needed 3 bullets in the zombie to die. So 1, 2, oh, maybe 2 bullets. Okay, and as you can see, the zombie is pretty much dead, but it starts attacking again as I get closer. Alright, so here I have to check again. So if not is dead, and we are close enough, then attacking. If the zombie is dead, but yeah, I think you get it. So now where it is, here we are, 1, 2, and dead. So we can get closer and perfect. Okay, I think that was a little ridiculously long tutorial, so I should stop right now, and later on I will come back to do some more stuff with the zombies and this whole FPS project. So thanks for watching and have a great day, and if you are still here, congratulations. Apparently in the last demonstration it seemed that I forgot that I only record a part of my screen, and wherever I played it was not one of that. So that's why I just cut this little scene to the end, so you can see how does it look like so far. Okay, the weapon is the same color as the ground, so it's hard to see, but it's there. I can shoot the zombie with 2 shots and should kill it too. Right, so the zombie remains dead. Although it's... yeah, no, everything worked fine. Okay, and as you can see, I can walk around and shoot things. Okay, so I just cut this little scene to the end of this video, and again, thanks for watching, and have a great day.